就 welcome our lovely Ian to continue his presentation. OK， 好，让给你喽，1:50我会叮叮叮哦。
OK， 那上次很可惜，我没有办法有机会有时间就是介绍我的城市。那既然今天有时间，我就想要带大家稍微看一下我的城市。然后因为我知道说就是可能就是有人会就是没办法完整看完，因为其实那个城市有200多行，所以完整看完的话介绍太低调，可能会有人介绍到睡着。所以我今天准备就大概跟大家介绍一下我那个城市的运作方式。好，那让我们开始吧。嘿嘿。那一开始我 include 了一堆东西，因为有很多运算法需要，也很多演算法是需要什么像分制啊，然后 vector 啊、stack、deque 这些都需要用到很多运算法。像我这边我每个输进来的阵列，因为对，我这样是在
Yeah, sorry.
Yes.
Would you mind to trying to use English?
Oh, okay, yeah, definitely. 好，那我全荧幕这样大家是不是看得比较清楚？Okay, so like lots of sorting algorithm that we using will have to include vectors and stuff like that. Because if we use like normal array, that the array will crack or overflow. Since like if we're sorting like a thousand, no wait, I think the array capability is 10 million. So if we are sorting our a number array over 10 million, then the array will overflow. So we have to use a vector because vector can store infinite, not infinite actually, but because vector can store as many as your computer memory can store. Not like an array. Array can only like store 10 million 10 million digits, so it's impossible for us if we are sorting like a really long number array using only array. So that's why I include vectors, so we can sort with vectors, and also that because we have lots of like large numbers, so we cannot use normal integer. We have to use long in order to not overflow. So starting at the first one, we have merge sort, and so actually this is the sorting part of merge sort. So we have to first look at the body part of merge sort. So as if you guys know, I think N will know this, that is that merge sort is using a method called divide and conquer. So first of all, if we want to sort if we want to use merge sort in an array, then as you guys can see here, you have to divide them into groups, into many small groups, and each sort them, and then sort the big groups, and then combine them all together. So first of all, we will divide everything into 2 small groups. So you guys can see in the body part here, we'll divide then into 2 small groups. So we'll find the middle, and so first, like this part is like dividing it into small groups, right? So first of all, we'll find the middle, and then we'll call itself again. So this method is called recursive loop. In 中文是叫做递回。所以in this function, we divide it into small groups, and so we find the middle. Then from the beginning, from the lower bound, so from the beginning to the middle, we divide them again. So we call this function, and we do divide them again. And and after I divide them again, I call myself too again. So I will divide from like for example, if I have 4 digit over here, then in the first time I will find a digit number 2, right? So from 0 to 2, I will call itself again. So this will then divide 0 to 2 to 0, 1. And then it will return 0, 1 and back to the first loop. Then it will return, then they will move on to the next function. So this one will call itself from 2 to like if I have 4, right? So this one will divide 2 to 4 into 2, 3, 4. So like using this recursive loop, I can divide a very big thing and into a small thing, and a small thing and a small thing, and gradually I will divide it into all individual parts. So this is using a recursive loop to divide them all to parts. And after I have divided them into very small parts, this is how they sort and they combine. So after they divide into individual parts, so they will finish all of these function, right? So let's finish of the divide, and so now we're going down to conquer. So in the conquer part, we'll call merge, which is up here, and this part will compare like which one is bigger, and then do the swapping, so the swapping position, and so this part is conquering, and this part is dividing. So this one is a divide and conquer within a recursive loop method in order to do a merge sort. So I don't know if you guys understand this part. This part is really 抽象, yes. So let's move on because merge sort is a really complicated sort, yes. And so move on to insertion sort. This one is way easier because for what is this one doing is that insertion sort is that I will sort everything I find immediately. So for example, I have an array called how about let's see like that. Okay. So first of all, I will sort 4. So 4 will be my sorted array. Then I will find 6 over here. Then I'll figure out that actually 6 is bigger than 4. So I'll put 6 here and delete 6 over here. And then I found out 3. 3 is smaller than 4, so I'll put 3 over here. And then so I delete 3 over here, and I found 8. 8 is bigger than 6, so I put it just right behind it, so 8. And then 2. 2 is just smaller than 3, so I'll put it here. And so I'll delete here. And what if I have a 5 or how about let's say 4 here? Okay. So then I found 5, right? So 5 is just right in the middle of here. So I will insert 5 over here and delete 5. So that's why insertion sort is called an insertion sort, because I will use the thing that I find immediately and insert it to the array that I found. So you guys can see that this is already a sorted array from 2, 3, 4, 5, 6, 8, like that. So that's how insertion sort work. Then this is basically the code. You guys can see that it's in sorting, yes. And finally print out the array and move on to bubble sort. Okay, so bubble sort is like think the easiest sort in sorting algorithm because that's what all the elementary programmers use. And for bubble sort, let's generate the array. So for bubble sort, that's how it works. So first of all, we compare the first 2 digits right over here. So you guys can see that 5 is bigger than 4. So we've swapped the position of 5 and 4. So it's become 4, 5 like that. And then move on to the next digit. We compare 5 and 3, and 5 is bigger, so we swap again. So 3 and 5 then. Then we compare 8 to 5. It will find out that 8 is bigger, so we don't swap. We just move on. And then we compare 8 to 0, and we will find out 8 is bigger than 0. So then we will swap this 2. 8, 0, 8, like that. And then we do it all over again. We compare 4 and 3. Then so 4 is like bigger than 3. So then we swap it. So like that. And then we compare this 2. Then compare this 2. And so yeah. After doing it for like n squares of time, so then we will successfully sort this array. So that's how bubble sort works, just like that. And so I think bubble sort is relatively easy for you guys to understand because like usually for last semester we have teacher BB's Python class and we teach about bubble sort too. So you guys might remember that from the last semester. Okay, then let's move on to quicksort. Quicksort is relatively very complicated because like quicksort is also using divide and conquer method, and just as you guys see here that we first divide like the quicksort into 2 parts. So yes, we sort a half and we deal with this half. Yes, so that's how the quicksort it will divide, like it will found that the bigger parts of the array and the smaller parts of the array and divide them and do the bigger parts first than the small parts. So that's how a quicksort work. And so it's relatively hard to to what's that called? It's relatively hard to introduce a quicksort because it's also using a recursive loop and also 2 function combination. So yes, so let's just move on with that code. So move on to selection sort. Selection sort is also relatively easy. And how a selection sort works is that okay, let's just generate the array. So how a selection sort works is that okay, so I will select the minimum value. So I will scan through the array. So 6 is now the minimum value, and after I scan 4, I'll find out that 4 is a minimum. 8, 3. Oh, so now I found the minimum value 3, and move on to 5. Okay, so we know from the first gaming, we know that 3 is actually the smallest smallest number in this array, we'll find a minimum. So then we know that we know that 3 has been in the first place. So we swap 3 and 6. So the second string will be like this: 3, 4, 8, 6, 5. So you can see that 3 and 6 change spot. And so for next movement, we're scan this array, and we found that actually 4 is the smallest, so we don't have to swap anything. So then we scan again. Oh, we find that 5 is the smallest. So then we will do that also. 5 and 8 will swap. So they will change the spot. So like that. Then after swapping, then we will know that so this one is the sorted array. So actually for selection sort, it's basically finding the minimum and put it in the very front. So that's how a selection sort works. So you guys can see that, yes, I record a minimum and then swap with the like in the very front value here, in order to move the minimum value into the front in order to sort this array. And after you guys hear me introducing this, oh my god, it's just 10 minutes. Okay, so after you guys hear me introducing all of this sort, you'll find out that I kind of like selection sort is kind of like taking time a lot, because you have to run through all the array and then it can sort. So you have to run through an array for tons of times. However, for merge sort, not really, because merge sort you just have to divide everything into small pieces and sort and combine, and that will work. So you see, like from the GIF pictures, the GIF pictures, you can know that actually merge sort is relatively quick compared to like other sorting algorithm. You see, you just combine them, and you can combine into a whole part. So actually merge sort is relatively quick compared to all the other sorts. And move on to my body parts of the coding. You guys can see that this is a timer, and I asked the user to input the number, the type of sort they want to do, and how many digits they have, and I just input, and I put them into all of the vector array. And so for each type, I start sort with different things. So for type 0, I execute a merge sorting algorithm, and for type 1 insertion sort, type 2 bubble sort, type 3 quick sort, and type 4 selection sort. That's how it works. And if it's an arrow, then you will see out present an error on the screen, of course. And so you can see in the beginning I start a timer, and in the end I end the timer. And in the very end, I'll print out that this program the time taken by this program is how many seconds, like that. So that's how I do my program, and how to do my data research and stuff like that, and move on. So I think I finished my research method and to the data analysis. So I think I showed you guys last time that how the growth rate change for this experience, but I try to draw it out for you guys to see, but that's how it's been presented if I draw it out. So you guys can see this 1, 2, 3, this is scale, and I draw y equals to x for reference, so you guys can see that y equals to x is over here, and you can see that all the other like rate of change is over here. You have to zoom in zoom in until here. Then you guys can see that that's how the growth rate of change is. So it's like really small for a human eyes to see. It's nearly impossible. So actually the red one is a merge, so you guys can pay attention to that. It's really small. Okay, so you guys can see that this is almost a horizontal line, right? However, it's not, because I can prove to you guys it's not. So you guys can see that it's a really small rate of change, and I'm going to prove it to you guys that they are not a horizontal line. So we are zooming in from a 0 part, right? So you can see that they are really small. And so let's move on to here, number 2. Oh shoot. Let's move on to number 2, and let's zoom in number 2. So you guys can see that initially the red one is on the very bottom, over here. But now the red one has has 超越 the black line. You guys can see that. So actually, you guys can know that those lines are not horizontal line, but they have the rate of change, but in very small amount. It's really hard for human eyes to see it from the graph. So it's nearly impossible to see. Okay, so actually for the conclusion part, I think I have shown you guys like this graph, this table I made. So yes, like whether like how fast they are, like in the best case, worst case, and average case, and how much space they need, and whether it's stable or not. So this graph is just for reference, since we are calculus, so we're more focusing on the speed, right? So that's how the speed and the rate of change, the acceleration of it. So that's how, yes, the speed change. So for you guys see that, because I cannot input a gigantic data size, so it's impossible for me to draw this graph for you guys. So I can only draw a graph for around here, like around 0. So you guys can see that the graph around 0 is like this, just like this. And so it's impossibly to see. And actually, so if you guys, if I zoom in a bit, so it's easier to see like how does it looks like in around the zeros. So you guys can see that actually merge sort is the fastest, because you guys see it takes the smallest compared to others, so compared to n square, like, and merge sort n square is over here and merge sort is over here. So merge sort is a relatively fast, is like the faster sorting algorithm, but sorting algorithm must take times, because for sorting algorithm they have to check every data in order to know which one is biggest. So I think O n log n is the fastest of sorting algorithm, which is a merge sort. And so you guys can see that actually merge sort here has a higher rate of change. The reason why is that because in the middle, in the beginning, not in the middle, in the very beginning, you guys can see over here, like right over here, the green line here, it has a what's that called, steeper rate of change. So actually this graph can present, like, it's like a tangent line for the sorting algorithm in this spot right over here, because actually this is 5,000 digits. So for my computer the maximum is 10 digits. So this 5 is representing 5,000, so 10 is like over, right, just right over here. And you guys can see that the orange one is n squared. So you can see that in the beginning, n squared has a relatively not that steep, has a smoother, or like 就是比较平一点的斜率. So the rate of change is not that big in the very beginning of n squared. So you guys can see that that is why, like for selection sort in the beginning, because selection sort is n squared. So in the beginning, why selection sort is not that steep, the rate of change is not that high, because that's why, because in the beginning that it's faster than those of n log and stuff. So that's why in the beginning, like in the very beginning parts here, you can see that the tangent line of merge sort is steeper. So yes, that's basically how my experience are. And because like due to the 硬体设备, yes, so I cannot like fully drop like all of the graph for you guys. I can only present you guys the instantaneous rate of change around the zeros. So yes, but yes, that's like I think this research is still like credible, 就是还是值得讨论的, because like normally like we talk of like rate of change, not rate of change. Normally we talk of like computer sorting algorithm speed. We use ON's like notation, big O notation to discuss the speed. However, those are discussing the speed like while the input data size is like 1,000, a million, or stuff like that. So that's how the growth rate goes. But no one ever discuss whether the rate of change in the beginning parts, which is like just yeah, so like 怎么说，就是零旁边的那些小质量的 input, there's like no one discuss about it. So in this research, like I can successfully like draw out how does the rate of change and how does the graph go just beside the zeros. So we can know that initially how does each algorithm speeds and how does each algorithm work. Yes. So basically that's all of my research. Yes. Thank you guys.
Fascinating. Ian，
Yes.
你未来是有打算确定要走资讯方面吗？
对，
还是再想想？
我很确定我应该是要走资讯方面。
好，我觉得你刚刚的东西都还可以再延伸哦。其实每一位同学呢 ，every student, your final project, if you want, you can just really, you can just find more information about, which is related to your final project and just extend the ideas. OK， 好，其实很不错啊，很不错，就是而且蛮清楚的 ，especially because you just gave us the examples. What's the difference between those sorting methods? Yeah, very fascinating.
其实我本来想要画就是一整个这个 graph 给大家看，就是给他看说哦，到几千几万的时候那个成长是这样，可是我的 computer 在一开始就 crack down 了，所以我只能画就是
对，因为那个像你研究的这种东西，它的那个电脑的确实是硬体设备要很好，对，要很好啦。对，没关系，没关系。Just for a final project for the AP calculus ABs, already very fascinating and very wonderful. Okay, so because of